Hello, everyone, and welcome to Code with Italians. Today, we have a guest, and I was thinking earlier how to introduce the guest, and then I thought of the Letterman show on Netflix. My next guest needs no introduction. So I was like, yeah, I think people know Jake, but hi, Jake. Welcome to the stream.
Yeah, thank you for having me. I'm sorry I'm not wearing our typical shirts that we wear at the conferences.
I actually picked one that I don't think you have today. That was a very deliberate choice. So today we are going to be spelunking into Compose in the sense of seeing what the story is, trying to figure out what you can do with Compose beyond what we are kind of used to at this point, so beyond what is known as Compose UI. We are probably going to complain about naming of things because that's what we do. Oh, thank you for the sub, Bowtie.
Thank you for the sub.
Yeah, we're going to go looking into the code, trying to figure out things. And Ivan, your turn.
Yes. So public service announcement. Because I can't be much of a technical part of the stream today, because this is going to be one of those, yes, Ivan, do you get it? Yes, sure, Anyway, so I'm focusing on the stuff that I can do. Today we have a lot of tickets to give away. We are also giving away the IntelliJ license, so you're still you can still join the giveaway. Just head on YouTube for look for the latest episode and type the word so we can Spike will understand more than even. Thank you, Mark. Ciao. Welcome to the show, Mark. It's a pleasure to have you.
For those who don't know, Spike is your dog that you can see in the background.
Yeah, Spike is the dog, and he also has a light. Let me pick the light. Do I have the light? Is this the light? Spike light? No. I don't know. Too much technology. Anyway, so today we are also reminding you that we will have chat with us on Sunday. So if you haven't buy the book, read the book, we will have a link for you in the chat in a moment. It's an affiliate link for Amazon, so we get like a few cents, and the rest, of course, goes to chat and charities, mostly charities, I guess. We are also giving away tickets for Berlin and London. I can't remember, Sebastian. Is it Berlin or London?
I think we have given away the ones for Berlin, and today is London. We have 2 free tickets for London, and I think a bunch of discounts. You need to check, as usual.
Yeah, I need to check. This is a lot of stuff to remind, so no stress. We will give you links over the time. So we want to also remind you. I'm just gonna put this in the chat. They leaked Twitch, like the whole thing. So you should refresh your password. And if you were wondering how many Teslas are we buying with the money from Twitch for the show, none. So that's the answer. Now you can check. If you don't believe us, now you can check how much money we're making on this. And everything that we are making, it's about stickers. So just to be clear. And that's it. I think we are almost
one last thing.
There was a nice
one last thing, Ivan. If you don't use 2-factor authentication, please set it up. That's going to save you in the future.
Yeah. Yes. I actually also got a notification before the stream about one of the tickets that you opened, Sebastiano, on the issue triggering, because Compose is missing the landscape preview. The ticket has been assigned, so there is there is hope that we will have
Are
it
we going
soon
to do
enough.
like a
So
bug
that's,
report bulletin from now on? Because we seem to be reporting a shit ton of
yeah, I
bugs.
mean,
It might take the whole
yeah, we are
episode.
reporting. You are reporting so much stuff. So, and I think that's
Yeah.
it from my side. I think we can start.
Jake, all yours.
Oh my. The only other thing I'll mention with you can change your password while you're watching. It doesn't actually log you out. So if you're already on here and watching, just middle click on your pretty face in the upper right and go to security. And you can change it without disrupting the stream. So do it right now.
Thank you.
Okay, yeah. So how did this get started? We had like a Twitter back and forth, but I don't remember what initiated it.
I don't remember what I had for lunch, so there's that.
Somehow we
But
got on the topic
there
of yeah, like I would come on and talk about Compose, and because you alluded to the naming, and
All right, yeah.
the naming is one of my primary issues with Compose because it feels like it undersells a lot of the underlying technology that powers what the general public or general developer community thinks of as Compose. And I wrote a blog post about this, and I tried to like evangelize a last minute naming change that never happened. But yeah, I wanted to quickly kind of start with how Compose got started, and that will lead us into looking at some other interesting applications of Compose that aren't just building your Android UI. So yeah, like Compose, what we know as Compose now really started as two totally separate projects. If you saw what Compose initially was proposed at, you probably wouldn't recognize it today. If you looked at the source code for Compose as soon as it was open sourced and moved into AOSP, you may have seen like an XML like syntax. I probably should have went back and found an example of this, but the original proposal was actually to not to fork the Kotlin language, but to like enhance it with a like an escape hatch where a compiler plugin could come in and basically get arbitrary syntax that otherwise wouldn't be valid Kotlin code. And the idea was that you could take the XML code, the XML structure that we've known for 10 years, and essentially mirror it in Kotlin, in type-safe, IDE-friendly Kotlin, in a way that's very similar to if you've ever seen like a React or Vue or whatever, where they're writing JavaScript, but they have these like angle brackets and XML-like literals. And that was the initial proposal. It was going to work for all your existing views, use the existing view system, anything that's built into the platform or in Jetpack. It wasn't Jetpack at the time, but in the support libraries or your own custom views, they would all just work with this syntax, and required some massaging, and the compiler plugin stuff was still there, but it was pretty wild. And there was no talk of a new UI toolkit. It was just this compiler plugin for changing how we interact with the existing view system.
Okay.
Yeah, it's just something. So like the XML in Kotlin is a pretty I don't know. It usually offends people when they first see it. I certainly was offended by it and thought that this would be a terrible idea. But actually, it's like, why wouldn't you use just function calls or whatever, like what we know today? And there was actually a lot of good reasoning behind why the XML syntax is superior to what we use today. And the primary example is if you have something like an image view, which can accept either a resource, r.drawable. whatever, or it can accept a drawable instance. And so if you use functions, you basically have to have two functions where that image property is different. One that accepts the resource and the other one that accepts the drawable. And then, I don't know how many properties there are in image view, but it's up in the tens. And so think of like text view, and it's like, it has drawables that you can put to the left, right, top, or bottom. And then they also added start and end for RTLs. That's like six drawable references, and now you basically run into like a combinatorial problem where the number of function overloads that you need in order to support like a text view function become like very quickly go to unrealistic numbers. Whereas in this XML syntax, because they have this escape hatch out of the syntax, out of the normal Kotlin syntax, they can support both types in a single position. And so you just say image equals and be able to pass in r.drawable or, you know, like a color drawable that you instantiate. But yeah, so it was interesting watching people become convinced that this XML syntax was like the correct way to go. And from what I remember, almost everybody eventually came around to it, except of course for the owners of the language, the stewards of the language, JetBrains, who, despite understanding, did not want to add this escape hatch to the language so that Google could build this XML syntax, which is what essentially forced Google into the function syntax, and inevitably sort of forced it into changing how we create the types that we create to minimize those number of overloads. And that sort of pushes you into not being able to use the existing view types, but to have separate definitions for things like images or whatever. And as the team that was working on Compose started going down this path, they very quickly realized that they had to change approaches. And separately, there was an effort to decouple a bunch of the widgets from the platform in the same way that like drawer layout and view pager had done. So there's going to be like a image view and a text view and stuff that were separate from the platform to solve compatibility issues. Those efforts sort of very quickly merged together and kind of became what we know as Compose UI today. So that's sort of like,
how many years was this? How many years ago?
I'm pretty sure that I heard about the project within months of joining Google, and that was 2017. I'd say it took about 2 years before it was publicly announced, and then that was one more year before it was, or a year and a half before it was 1.0. I think it was
after.
Yeah, go ahead.
I was wondering if you, how do you consider JetBrains' decision, like in the light of, okay, we started in a way, this is where we ended up. Was it a good call, or it was like, I mean, did the constraint forced creativity somehow? Would you say that it was a good call?
It definitely was the safer call. Once you introduce something like this, I mean, it opens up a lot of other possibilities. So, like, really quickly, if there was something like an escape hatch where a compiler plugin could come in and support arbitrary syntax at like inside a function or whatever, I mean, I can immediately come up with all kinds of use cases for that. Like at Square, we have a plugin called SQL Delight where we basically create type safety around your SQL database. And imagine if you could just write that SQL query like directly inside a function in plain raw SQL and have a compiler plugin, not inside a string, just sort of like inside a position of your function, and have a compiler plugin come in, hoist that out into something that has all the code to create a prepared statement or whatever, and fill in all the positions appropriately with the arguments that you're passing in. Like, it's an extremely powerful mechanism that allows you to extend the language in a way that the people that work on Kotlin just can't foresee. But the huge downside of that is then the story around tooling, especially IDE tooling, becomes much, much harder. And of course, Kotlin and being, JetBrains obviously being very IDE forward in how they build things. I think that was actually one of the primary reasons that they said no. They didn't want to sacrifice their ability to really control the IDE story for the entire language. So yeah, it's definitely the safer choice to say no. And there's of course all kinds of ways that you can express things in Kotlin in ways that you can't in other language. Obviously, the DSL mechanism is extremely powerful, and it still works very effectively for Compose UI, but something more, something completely different, like a SQL query, you really have no mechanism there other than a really, really complex DSL that looks nothing like SQL, or you put everything inside of a string and you sort of lose, you lose the advantages that you gain otherwise by trying to build like a language inside another language. So I certainly understand the decision. And Kotlin is a very young language. Making a decision like that early to have such a powerful escape hatch could easily turn around and bite them in 1 year, 2 year, 5 years, 10 years down the line.
And that was a long time ago, because like Kotlin is 10 years now, but it was what, 5-6 years at the time.
Yeah, so that would have been right in like the 2018-ish time frame.
Okay.
So yeah, I think ultimately what Compose UI became and what it was able to do with just functions and DSLs and compiler plugins is good enough. It may be, we'll never really know like what Compose would have looked like if the XML like syntax was explored for another 2 years. So we'll never know whether that actually would be successful, or was able to model things better than what we have now. But certainly now it's what they've managed to build is really impressive.
But was the XML syntax still a reactive UI framework, or was it still just like a Kotlin way to express the same thing you would do exactly the same way?
No, so it still was reactive. It basically was exactly what we have today, just with a different syntax. You literally can imagine just taking anytime you call an uppercase function to define a composable and changing that to have angle brackets, and like any of the trailing lambda, like the content lambdas where you put stuff inside other stuff, would just be normal XML like nesting.
Mm-hmm.
So yeah, and like obviously it's not XML directly, because you can define things like lambdas, like your click listener was an attribute on the inside the XML declaration. But yeah, it's not in terms of like the functionality of the framework. It was essentially exactly the same, just syntactically a different choice.
Got it.
Yeah, but so that's sort of how we got to where we are today. And one of the things I like most about, I'm not sure if it's, I didn't work on Compose at all, and didn't even really use it until the months leading up to 1.0. And so a lot of the like decisions that or the way that it's built that I really like, I'm not sure whether it's a direct effect of some of the ways that it evolved, or were intentional decisions, or maybe both. But one of the cool things about it is that the very, very core of Compose has nothing to do with really Android. It has nothing to do with UI toolkits at all. It's really this completely general purpose hammer that you can hit like a bunch of different style of nails with, as long as like the problem you're trying to solve can be modeled as a tree of objects. And so like UI systems are very much trees of objects. The view system that we have today on the platform is it's like the most basic kind of tree that you can build, where each object just has its child views And then when you perform anything on it, it just does, like standard tree recursion to go down and do like measuring passes or draw passes. And you look at something like Compose UI, and the tree is still kind of there that you can see in the way you call functions. But underneath the hood, it looks almost exactly the same as the existing view system. There's a type that is, it's called layout node. It is the node that sits in a tree, and it has a set of children. And so when you're writing all these function calls and passing arguments and stuff, really all you're doing is creating a tree of these layout node objects and setting properties on them. And then the way in which it gets to the like pixels on the screen is almost exactly the same as how it does in the view system, where there's just these recursive kind of calls down where each node just draws basically to a canvas based on the properties that are set on it. I could if I had started by describing that, you probably thought I was describing the existing view system, not Compose UI. Mm-hmm. But under the hood, it's like shockingly similar in the ways that it works. It's just the way we declare how these trees get created is, it's literally like code declarative and function calls rather than the XML, which is also declarative, just not as dynamic and certainly lacks a whole ton of type safety and stuff. But they're like not as dissimilar as people think in like the mechanisms that underlie them. And you look at any other UI framework, and you're going to see the same pattern over and over again. The web is just a tree of objects that they call the DOM, where there's nodes, and the nodes have children, and there's these recursive walks that draw to a canvas. UIKit on iOS or macOS or wherever, it's the exact same thing. UI view is just a node in a tree, and there's these recursive walks down it to do measuring passes and draw passes and stuff. And so getting back to what I was saying about the core of Compose, if you have any problem that you can represent as a tree, or you can take a tree as its output and turn that into something that you want, you can model it with Compose and gain all of the things like the automatic reactivity and the incremental updates to that tree that we get with Compose UI, but with something totally different in terms of how it like renders. And by render, I don't necessarily mean like to pixels, but like how it manifests to wherever you want it to go.
We have a couple of questions in the chat. So the first one was from Gianfranco_MS. He was asking, well, they were asking, but I assume given the name, does that mean that we will soon see Compose for iOS? Wink, wink, Jake.
Yeah, it's a good question. And this sort of goes to the lack of specificity around the naming. If you just want to run Compose, the core of Compose on iOS, you could do that today, and you've been able to do that for about 6 months. JetBrains worked on the Kotlin native version of the Compose compiler. It basically required a little bit of changes to how the compiler is sort of very general purpose and how it works. It interacts with the Kotlin's IR, which is like halfway from being Kotlin source code to the compiled code. There's like an intermediate representation, which is where compiler plugins get in and move things around. And so like 99% of the Compose compiler runs on JavaScript when you're targeting JavaScript or targeting native. But that there was a little sort of like 1% extra that was needed. JetBrains worked on this and upstreamed it into the Compose compiler in AOSP. Now, just running Compose on iOS is in and of itself useless without that tree that you're producing. And so if you're talking about running Compose UI on iOS, that's a very different thing, because Compose UI is a huge set of libraries and interactions with things like native components. And that will that's a more monumental effort to port. But if you want to target some other tree, like maybe the UI kit, the existing UI kit framework, you can do that. And it's actually not that hard. Like it's really only a few hundred lines of code. And so we actually did this for a project I'm working on at work, where we're sort of doing something in a multi-platform context where we want to target both Android, iOS, and the web. And we actually target UI kit on iOS using Compose. And we use platform agnostic composables. So you're still writing like a button, but the properties of that button are sort of watered down to be much simpler. And that allows us to map those properties to an Android, like an Android.widget.button, or a Compose UI button running on Android, or an HTML button running in the browser, or UI button, or whatever, I don't remember what it's called on UIKit, but it allows us to target these different UI frameworks with the same Compose code. Obviously, that requires just like a ton of other infrastructure around it. To do that, it's not something that's like you can take your existing Compose UI code and get it running on iOS in no time. It's really more for stuff that's being built fresh. And it will hopefully be open source eventually. It's just a very, very big and kind of slow project. So it's sort of a long-winded way of saying, yes, you can run Compose on iOS, but usually no, it's not what people are thinking of. Although technically there's very little like technical blockers for running Compose UI on iOS. There's just a lot of work that needs to be done to have that. And also there's the question as to whether that's something that really makes sense. Does it make sense to abandon the like intrinsic UI toolkit of a platform? You can argue that Compose UI on Android is becoming the new UI toolkit that we expect Android applications to run in. But does that same rendering engine make sense running on iOS? If it looks, like Material or whatever, and doesn't make sense even running on the web or anywhere else. On desktop doesn't make sense. That's something that exists today. And so, yeah, like I don't think it's even just a technical question. There's sort of more of a question as to whether that's something that's appropriate for your application. Certainly there are multi-platform frameworks that don't hesitate to throw away the entire platform toolkit and re-render everything on every platform. And that's a choice they make, and that's a choice you have to weigh as to whether that's something that you think is appropriate for your application and the users of your application.
And we're not naming names, but we all know what we're talking about.
No, and we're not saying that's the future either, right? So just don't. So jokes aside, you keep saying tree, right? If you have a tree, you can use Compose. And you have a tree on web, you have a tree on Android, you have a tree on iOS. So the output, you can actually somehow plug it, and you can bridge the two words, and you can use Compose for that. And that's fairly clear, even for somebody that doesn't know anything like me. My question is, what else would it be possible to do? I mean, I'm not familiar with things that can be modeled with a tree, either than UI. I mean, I'm a very simple person. So what else can you do?
Yeah, I think ultimately one of the problems with this is, even if you model something that is not considered UI, it usually ends up as being something that's displayed. And so it sort of like becomes UI no matter what. I mean, you can argue that Compose UI, the output of it is not UI, it's a tree of layout nodes, and then they also just happen to take that tree and call the draw function and pass it a canvas. But otherwise, those two things are actually kind of totally separate operations. And so, to take your example here, or your prompt, I one of the things when I first heard about Compose internally at Google, well, my first thought was I want to recreate this JavaScript framework I had heard about called Ink, and I should have had the link ready. I'll paste it in the chat, but it is a oh, I had to agree to not be an asshole before I paste things in the chat.
Oh, welcome, first time chatter.
Yeah, that.
Yeah, this is my first time prompt. Ink is Ink is a library that takes React, which is a web framework that has very similar properties to Compose UI, and it runs it in your terminal, your like console or whatever. It allows you to write. It allows you to write a command line application. Yeah, using React, and so you have like text nodes and layout nodes like rows and columns, and anytime you change values of the state that you're using, it will automatically re-render the output to the terminal. And so when Compose first started, it literally was a fork of the Kotlin repo, and in order to use it, you had to build all of Kotlin, which took like 2 hours, and so it was very hard to do something like this early. But after it had been open sourced into AOSP, it was sort of greatly simplified. And after I left Google, I was able to spend some time on this, and I produced a very close lookalike called Mosaic. I see someone already spoiled it with what it is. It's extremely similar, and even the sample that is rendering in the terminal there is one of the ones from Ink. Like I literally took their sample and I changed I used to have the file extensions had .js, and Rahman yelled at me for having JS as the file extension, so I quickly changed it to JS, or to KT rather. But it's the same principles where you get to, if you scroll down a little bit, you can sort of, it's a little tutorial as to how you can set it up, but keep going down a little more. Okay, that last one right there in the middle sort of shows you something that should look very similar to what you're used to if you have used Compose UI, where you create a state object that holds values. You have a composable lambda, which is that set content lambda. You have composables that produce some sort of visual representation, which the text one is, and then below that you have sort of like that for loop is like your application or your presenter or whatever that's actually running. So this example is just counting to 20 with a delay.
Yeah.
But that notice that like you never invalidate like the UI. You never deal with how to update anything. Compose, the Compose core, the mechanism that when you change an image on your image composable in your Compose UI, the mechanism that automatically updates that attribute on that node is basically being reused here to update an attribute on a node that just happens to render to a terminal UI. And
to a terminal. So you will literally use it as an Android app or a desktop app. I mean, that's the same syntax. That I will have no problem to build something like this with the little Compose that we know, and I can build a. I mean, this is super cool. I mean, because when you back in the day, if you wanted to build something on the terminal, Bash and that kind of stuff, it was like a struggle to do even the bare minimum UI, right? But this is actually super handy.
Yeah, it really is. One of the things why I think Ink is really powerful is it allows someone that's a React or even just a web developer to take knowledge that they have and apply it to create something in a domain that they otherwise would have, it would be harder for them to produce quality output. And so if you've interacted with Compose UI and you've done a little bit of it, all of that knowledge of like how composables work and how the state objects work, and none of those examples use remember, but like all that stuff is the core of Compose. That all will translate. And really, ideally, you only really have to focus on like the meat of your application, what it's doing to produce the output, and not have to worry about, how do I do colors? How do I go back and erase something that I've already drawn? How do I space things out automatically? Like all of that just gets taken care of for you, and you get to focus on what makes your terminal UI unique.
This is so cool.
But yeah, if you're in the repository, if you, let's see if I can do this. If you click into Mosaic, if you scroll all the way up, Mosaic folder, the Mosaic runtime folder, source, main, and then there's a nodes, KT. You can see concretely what I'm talking about when I talk about a tree of nodes. There's this Mosaic node class, which is it's an abstract class. It's sealed, so it's abstract. And then there's two. If you scroll down even more, there's two subtypes. There's a text node, which puts text, in. If you think about a terminal, it's basically like a really zoomed in, two-dimensional grid of not pixels, but like squares that you can put a letter in. So you have a text node, which can hold text at a position that goes off to the right. Or if you scroll down a little more, there's a box which just holds text nodes either horizontally or vertically. And so these you can imagine these forming like it's not a binary tree, but because you can have 3 text nodes underneath a row or something. But you can imagine these forming a tree of nodes, and the way that it renders is that it basically just recurses down the tree and says, text node object, how wide are you? Like text node 1, how wide are you? Text node 2, how wide are you? Text node 3, how wide are you? And then, you're in a row, so I know that I need to sum your widths to produce my width, and our height is just the maximum height of any child. Like pretty sort of basic fundamental like walks of a tree, and just really simple either addition or like max of math, and that gets you the size that you need to render and the positions at which each node renders. And then you just do another pass where you say render at this position, write your text out at 19 rows down and 20 columns to the right, and then every text node just renders its text, and you get the output. And so each frame you're seeing there is basically the entire tree the entire screen is being cleared, and all the text is being re-rendered. But it's so fast that there's not even like a flicker or anything. Nice. I see a question about why is the name Mosaic. The definition of a mosaic in art it's a piece of art that's comprised of smaller individual, like potentially colored or textured or patterned pieces that are then composed together to produce. Notice the word I use there: composed together to produce a larger picture. And so, it fit really well in the term of.
It felt appropriate.
Yeah, it's composed. It's it has sort of the smaller nodes being put together to produce a bigger picture. And actually, I found out after I rejoined Square that they have a internal project called Mosaic that I think they were going to open source that they had to rename because it like used Compose. It was like a UI thing for this other organization. They I think they had to rename it.
Is it called Mosaic 2
clashed
now or something?
Yeah.
Maybe
Yeah,
Mosaic
it was
UI,
like a
right?
more. It was more of like a design. I think it was more of like a design system thing for both apps, but like the Android one was built on top of Compose, and yeah, I
by
thought
the
that was
way,
funny. It's like other people found the name Mosaic for basically similar reasons, so that sort of validated that it was a good choice, and thankfully I got the first mover advantage where I get to hold on to it.
I think it's worth reminding people that are watching, because we keep mentioning Compose UI and Compose Runtime. Maybe it's worth giving them a brief overview of like what is what in general.
Yeah, so Mosaic is built on two pieces of Compose. It's built on the Compose compiler, which is sort of the easiest piece to understand. It's the Kotlin compiler plugin that goes in. It finds any function call to a composable or any function definition that is a composable, and it rewrites it a little bit in order to allow the reactive runtime behavior that we desire to happen. The easiest way to think about it is it's also very similar to how like the coroutines compiler plugin works, where you write a suspend function, and what actually happens is there's an extra parameter that gets added on, and the return type of that function is changed. And so the Compose compiler plugin does something similar, where it actually adds two or maybe more attributes to every function, so that it can sort of keep track of things. And then it's built on what I call the Compose core or the Compose runtime. The problem here is that like there really are no specific names for this from Google. I'm sort of making these up. They're all kind of called Compose, and there are things called Compose UI, but even that is a little nebulous. And so it's built on the Compose runtime like core, which is just the absolute minimum set of APIs that you need in order to define a composable function and keep track of define state and keep track of state using things like remember. And those are also the APIs that the compiler plugin will look for. It will look for the at composable annotation. It will look for calls to remember. And so all of the APIs that the compiler plugin looks for exists in this core Compose artifact. Then from there, there's a few layers on top of it. There's actually other artifacts in like the Compose core that are really specific to UI and probably shouldn't be there. But the next layer up is really kind of like the foundation layer, which is it's general purpose composables and sort of helper classes for building arbitrary UI toolkits on top of the Compose runtime and compiler plugin. So that's called foundation. It probably should be called Compose UI, that layer. This is going to get really hard to keep track of because it's things for building UI frameworks on top of Compose. Hence why Compose UI would be a good name for it, but it's called foundation. On top of that, there is what we sort of know as Compose UI today, which is really an opinionated implementation of a UI toolkit originally for Android, also now runs on desktop, but it is like a it's opinionated. It's not general purpose in the sense that you could build. You sort of can render arbitrary things with it because you can customize coloring and how things draw, but it's still like a specific implementation of a UI toolkit, not a completely general purpose thing like Foundation is that you might reuse. Like Foundation, you can in theory could reuse on iOS. That's a bad example because you could probably use Compose UI on iOS as well, but it's really blurry and hard to accurately define these things. But those are like the 3 layers I think of: Compose, the Compose runtime and compiler plugin, the foundation layer, which is general purpose utilities for writing UI frameworks, and there's Compose UI at the very top, built on top of Foundation, which is a specific UI toolkit.
It's very specifically material. Like
it, yeah, definitely. It's definitely hard to get away from material things at that layer. I mean, there's also like material, which is sort of adjacent to Compose UI, but also kind of intermixed with it. It feels, unfortunately, like this stuff evolved over time, and so things kind of had to be teased apart where appropriate. Things were merged, and it's not perfect because it was a multi-year evolution, and the UI toolkit came in after the core of Compose, and so I just find calling the whole thing Compose, like ultimately we've talked a lot about the core of Compose and how cool it is and how it lets you build powerful things like Mosaic, running on iOS, running on the web, whatever. That all, when we talk about, when Google specifically talks about Compose, they're really talking about Compose UI, their specific UI toolkit built on top of it, and underselling the fact that there's a complete general purpose, like I almost called it a toolkit, which would have been a terrible
thing.
That was close. That was close.
Yeah, naming, man. Yeah. A complete general purpose.
We solved the problem, but you don't want to know how. We solved the problem of naming things, but I would not advise letting your audience pick the names of the variables. It doesn't go good. It doesn't work well with the maintenance. But I see the struggle.
I saw a bunch of references to naming and spaghetti variables early on here in our chat.
Yeah, mostly Mark Ellison. Hi, Mark, we love you, but still.
Yeah, it's unfortunately, I think the naming thing has come up multiple times. When I still was at Google, it came up a few times, and I gave one really hard push towards the end after I had left of fixing the naming. But yeah, I feel like it undersells this technology that sits underneath Compose UI that very, very much is general purpose. And then that's just Google. JetBrains is also not without a little blame here for muddying the waters of Compose naming, because you have Compose Desktop, which is Compose UI adapted to run on the JVM on desktop platforms. But you also have Compose Web, which is not Compose UI. It's just the Compose runtime and a set of composables built for targeting the DOM, the HTML tags that you're used to. And so those sort of have the same naming structure, Compose Desktop and Compose Web, but are dramatically different in the types of composables that they offer. And Compose Desktop, like we don't call Compose UI Compose Android, but Compose Desktop and Compose UI for Android are essentially the same APIs, such that you actually can share composable, like you can share your rendering code across those two platforms, whereas Compose for web you cannot, and is a totally separate set of APIs. And it's why I really wish like Compose UI was just had like its own name. I don't care what the name is.
Let's call it Carl.
It has something that did not have Compose.
Let's decide today. It's called Carl. Yes. That's it. It's Carl.
Because then you would have like Carl Desktop, and Compose for Web would just be called like something also completely unrelated, but in a way that you knew that those two were separate products that you can't share things between, but Android and desktop you can share things between.
Yeah, that would be much clearer as opposed to saying, oh yeah, Compose multi-platform, which yes, there is a common foundation, but then they're two entirely different beasts for what I've seen.
Yeah, it just becomes, because there's a lack of specificity in the names themselves, you keep having, I keep having to add qualifiers when I talk about it to ensure I'm communicating to someone the same thing I'm thinking about. So to say, Compose UI running on Android, or the Compose compiler plugin, or the Compose runtime core, which also is just the name I've sort of made up. Running on the JVM for Mosaic or whatever. You just end up having to put all these qualifiers before you say the actual thing you want to say to ensure you're communicating the right piece to the other person.
Ivan, what do you think? Is it time to give away tickets?
Yes. So let's go. At least we can start. In the meantime, that we go on, people can join the giveaway. So we can do a bit of things in parallel. So for the next 5 minutes, we are gonna run the giveaway for the tickets for DroidCon London. So DroidCon London, god damn it, it's gonna be an in real life event that I won't be able to go, and this is pissing me off big time.
But I will be there,
yeah,
and
okay,
I will have stickers for you if you're there.
Yes. So I want to take the win. So 50% of the project is gonna be there. Thank you, Sebastiano. And he's also gonna carry 50% of the stickers that we have. So this is super legit. So for the next 5 minutes, if you type in the chat the word tomato, you can join the giveaway. Type it once, otherwise the bot is gonna disqualify you. So just once, lowercase, the same way you see it in the chat, you can type it. I'm gonna run a 5-minute timer. So the timer is running. Let's go. We can do whatever we want.
So in the 5 minutes we have, let's go with the silly questions that people have asked.
I see people are baiting.
Yeah, do you think that Flutter is the pizza with pineapple? It's okay that people like it, but it feels weird. I think that's a leading question.
Yeah, I mean, I could talk about Flutter for a long time.
You have 4 minutes and a half.
All right, I'll do a 4-minute. I think there's a lot of really, really awesome things inside Flutter. I just think it's completely inappropriate that it's from Google, because they both control the Android platform and Chrome, basically de facto web platform. And it's really irresponsible to just arbitrarily create a third platform because you're unhappy with the constraints of the existing two platforms, and then have the marketing for that product basically throw the other two platforms under the bus. Just
yeah,
really, and also the technology choices are just ridiculous. Dart Dart should have died. The Chrome rejected Dart.
That's exactly what I was gonna ask. I mean, you were there, okay? And I mean, you were there, man. You were there, like PTSD kind of thing. But give me one reason why not Kotlin. Like, why Dart? Right?
I definitely wouldn't do Kotlin. I would probably do TypeScript if I was in control.
Fair enough. Fair enough.
Yeah, you need. So the premise is really fast development time, really fast development turnaround. So you need something that can be interpreted. I'm not sure if you actually can interpret TypeScript. I mean, now there's Deno, which actually runs TypeScript without transpiling into JavaScript. But anyway, one of the core promises is the development turnaround time, and so you need something that's really fast for that. You have to have that. But then you also have to have something that AOT compiles to native, so it's also really fast when it runs in the binary. And I feel like Dart was almost perfect because they already had it. Literally nobody used it. The entire web platform and Chrome rejected it. It was rejected as a server-side language. And so it was basically this unused project that they could do whatever they wanted with. And so that team just sort of,
okay.
I guess.
So there was the freedom behind the tool itself was the selling point.
Yeah, but it really, so like kind of on topic with Chet's book that you're talking about, one of the reasons that Android chose Java as a language is because they wanted to reuse the entire corpus of existing Java developers and a huge subset of the existing Java libraries and have them work day one out of the box on the Android platform, which basically, it gave them thousands, tens of thousands of developers on day one. Whereas
everybody was an Android developer. I mean, can you code? Yes. Do you have an iPhone? No, you are an Android developer now. That was basically the statistically speaking, that was how it worked 10 years ago.
But yeah, to bring this like an entirely new framework and language and library ecosystem along with you. And force people to basically come up to speed and to build out that ecosystem is just a huge undertaking. And I would be so much more comfortable with Flutter if it wasn't from Google, because it just feels so, I think it's really telling as to how internally Google works or maybe doesn't work together. Because if there was somebody at the top of the company that had this overarching strategy for, their development ecosystem or whatever, like they never would let something like this out of the door. But because these teams are really so independent, things like this can thrive or die on their own. And Flutter really came at a time where it could snap up a bunch of Android developers that were, sort of basically pissed off with things like the speed of development on the platform, and certainly web developers that wanted to target native. Like Android and Chrome have sort of been fighting each other for things like the developer ecosystems of apps that are being built. Android certainly hasn't been elevating web apps to the same level as native apps on the platform. Like maybe if they did that, Flutter wouldn't need to exist, because then you could just write a web app and it could basically be installed on Android like any other application. And the same with Chrome, where like they needed to be doing more things to bring the functionality of native. I mean, Chrome has actually been doing the most, where and the web in general, where they've been bringing all these functionalities of the host system, like WebGL, like certainly access to USB and Bluetooth, camera and microphone stuff. The permission system was always way farther ahead than Android, where everything had to be approved rather than allowed out of the box. It's just
it definitely.
I've gone more than 5 minutes already. I feel like I could go 50 minutes on this, but shouldn't.
Yeah.
It definitely captured like a sentiment, because Flutter first came out when Android development was I don't want to say in its darkest stage, but it wasn't at the brightest stage either, like native Android development. And I don't know if it's anecdotal, but it seems to me like the vast majority of people doing Flutter are Android developers that are kind of moonlighting on iOS and on web and on desktop sometimes, but they're primarily developing for desktop. So I don't know.
Yeah, I mean, you think of when it came out, it's like Gradle was in its like awkward teen years, when it was as useful as it was also a pain in the ass. Everyone had gone too heavy on adding things like annotation processors, Gradle plugins. Our builds were just a mess, and it's insanely slow. IDE experience also not great. It was just it was a sort of a dark time. It was an unfortunate time, and you have a product where you come in and say, like, I can turn around code reloads in seconds, then you're going to get a lot of people.
But
also they lie out their ass with things like 1,000 FPS. Does anyone remember that when they claimed they could do 1,000 FPS? Ugh, such a lie. People on the Android team had to help out the Flutter team to even reach 60 FPS, and this was years after that 1,000 FPS bullshit claim. I don't know. Am I allowed to swear on here?
Yeah.
This is not family friendly.
We're very friendly, just not family friendly.
But we make pride out of it.
We do live coding, dude. Swearing is part and parcel of the experience.
It's in the title of the stream, so we can do whatever you want. This is a relief valve, so we can do stress relief. But jokes aside, I mean, first of all, 1,000 frames per second bullshit. I mean, what are you running? Like, I mean, it's like ray tracing. What's the next thing that they do? Ray tracing. But I don't understand. So okay. So I tried Flutter because, you know, science, okay? And the hot reload thing, it gets you for a moment, right? I mean, if you are working with Gradle, it gets to you very quickly. The fact that you press play and the thing just shows up on the phone. But then, you know, the whole thing feels brittle, you know, and then you're like always like, what's the return of investment long term? Is this thing? I mean, I'm gonna have pushback from the iOS people, and I don't know. Probably there are problems that Flutter can solve, but from an Android developer point of view, I'm still always like, you know, I don't know. I will, but I see what you mean. Like, you know, when it's sponsored, I say sponsored by Google that heavily, it feels awkward.
Yeah, I mean, there's even aspects we didn't mention, but I sort of alluded to earlier with the like throwing away the native UI toolkit on every single platform and having to re-implement that. So they basically like, so say iOS 16 comes out tomorrow, which is obviously not, but in features are redesign. The Flutter team has to go and re-implement that entire UI redesign in their system to try and match it as close as possible, because they've chosen to throw away everything from the native platform. That's just like, that as a decision just doesn't seem like one that's wise in the long term. Short term, sure, like it's probably a lot easier to do that. And they get a gimmicky thing where they can make it render and look like iOS on Android or like Android on iOS. But do you always want to be chasing? You're basically like trying to escape the uncanny valley of, you know, UI rendering, where I don't know. I mean, if you remember back in like the Xamarin days, or when a lot of apps were using these alternative things, and you would like scroll a list, and you'd be like, I know that this app is built using something other than a native framework, because like it just doesn't feel quite right. And now so they're always going to be chasing that
with Android 12.
You know, the ripple changes, the springy thing. Like they're always just going to have to be chasing that.
Ivan, do you?
Yeah, but at some point,
do you want to run the ruffle?
Yeah,
because otherwise we're going to end up like
have a lot of
in 20 minutes and we still are talking about this.
Well, no, let's go. So the raffle is over. Congratulations, Dr. Ampelt, for winning the giveaway. So I'm gonna just reach out, and we are gonna.
We have another ticket.
I'm gonna just ask you.
We have another ticket.
Do you want to do another one?
Yeah, we have two. Let's do two.
Yeah,
sure.
Another
Let's do two.
Roll it again. Bam.
Boom.
Here you go. Illusion
FPV. You're welcome.
Congratulations. So you are welcome in. This is so cool. I just need to, we have so many people in the chat that I'm losing. I need to stop scrolling. Okay. So I'm going to reach out and add you as a friend, and then we can I can give you the code. I guess it's a code that they have to use during checkout, right, Sebastian?
Probably yes, I think so.
Ish.
Yeah, I need to double check,
yes.
but yeah.
Yeah.
By the way, I think to save some time, we're gonna give away the IntelliJ license on Sunday, maybe. So you have more time to
Okay.
subscribe on YouTube
Fair
and
enough.
leave a comment on the video from Sunday. So we have some more time today with Jake, which I think it's flying, and I'm loving it. I'm also not speaking much, and a lot of people is pointing that out in the chat, but it's good. It means that I'm learning, that I'm that I'm absorbing notions.
You are also not coding. That is also good.
Yeah, that's why the stream is surprisingly family friendly today.
Yeah. Wow. Okay, so this was a nice bunch of anecdotes, and I thank you for this, because I need my share of this kind of discussion with our guests. So let's go back to what actually people are interested in, and it's not just some weird obsession that I have. So what do we want to do now?
I don't know, Jake. Do you want to cover something else? Do you want to do some code spelunking? Up to you, really.
Well, I can make a little segue here where we can start looking at
Go
code.
for it.
One of the interesting design decisions that differ between Flutter and Compose UI is the decision in Flutter where everything is a widget, and in Compose UI they have a modifier concept where the widgets are much more what we think about as widgets, are closer to what we had in the old view system. They're certainly more granular still, where you get a little lower level components, but we don't have like a padding widget or a margin widget or like a background color widget. And so Compose UI, that's actually not true historically. Compose UI started with everything as a widget. Compose UI, for better or for worse, started as basically just a near direct port of almost everything that Flutter was doing for the declarative UI and the way that UI was built. It served as the starting point for the new UI toolkit. And so it did start with everything being a widget, and then the idea being instead of your code like very quickly drastically moving to the right of your IDE because you had so many widgets, you would grab a set of them and refactor that, like extract a function that would be your button that had your design system's padding and color and the correct, ripple or animation or whatever. And then you could build up these higher level widgets yourself, which, as I understand, is sort of what you need to do to make Flutter's UI system a bit more palatable instead of everything turning into a giant, Christmas tree looking thing sideways.
Yeah, more like a Street Fighter Hadouken kind of thing.
Yeah,
right?
yeah.
That's.
But yeah. So over time, that pattern of everything being a widget became something that I think there really were two things. It's just that it didn't feel really satisfying having that, and also there were limitations to that system where one, like an inner widget can't really see into any of the outer widgets that enclose it, or even vice versa, where an outer widget can't really know that something inside of it is being is set up in a particular way where they need to know about each other. And so and I'm sure there were a few others that I just simply am not aware of, but the decision was made to switch to this modifier pattern, which I think is a really interesting design in how Compose is set up, because it's almost like tiny little composable, like every node that has a modifier is like a tiny little I hesitate to say composable, but it's like a tiny little UI toolkit in and of itself, where you have all these modifiers stacked up. And so if compose turns into a tree, and that's what gets rendered, modifiers are basically a list, and they're like a visitor pattern at every single node. So as the tree is like measuring or rendering, and you're like doing recursion down the tree, when you visit a single node, what actually happens is at that node, you walk this modifier list and allow it to modify the values or the drawing or any of the like properties that these nodes are exposing to the world, in a way that you can much more easily reuse functionality at different nodes than if everything was a widget. So now you can take things like anything that's a listener, or modifiers that add like padding, or like maybe like a padding, a border, and then more padding. You can take those modifiers and apply them anywhere without actually having to alter the actual like function structure of your composables. You're never like wrapping something in something else and having to change how that code is structured. You can, for lack of a better term, it's composition again, where you can compose that into the modifier list rather than into the tree itself. It's just it's just like a really clever, it's a clever pattern, but it also has some interesting downsides where in the Flutter system, if you set up something where say you have like multiple levels of padding, you have padding and then you draw a border and then you have more padding. If you say change the color of that line, that border line that you're drawing, the only thing that will change, because those nodes are like part of Flutter's tree, the only thing that will change is that that property on that like border node. But in Compose, we haven't really talked about how like composable functions work, but in Compose, what actually has to happen is that entire modifier list has to be recreated. And so it's actually like a little bit more expensive. This is a very small operation, but it's more expensive in terms of when you change things inside the modifier list as to what happens when that code gets rerun to react to changes. But I think like that's the trade-off that was made, was sure, it's a little slower and may allocate a few more objects or whatever, but because it's so much easier to move around modifiers and to group them and have them apply to more types, it's like it becomes a more powerful system, and that's what's desired more than ultimate performance or whatever.
Something that you are saying that it got me curious. You keep saying modifier list, right? And you also mentioned that it's a visitor pattern. You reach a node and then you start applying the modifiers. So is it a list? Because Seb showed me that order matters, and then if you start putting padding and then colors, the whole thing just looks weird. So is it because it's a list? I mean, is it actually a list? That's why the order matters. It's not a set, right? I wouldn't call it a set because order matters, but you keep saying list. So now in my mind, the thing starts make even more sense, being the order meaningful. Is it correlated? I don't know. I mean, am just making it up?
Yeah, it's almost I tend to like want to visualize these things. So if you visualize the tree of nodes where you have like your row, 2 columns, and each column has 2 buttons underneath it. The modifiers are almost like depth in that tree, where like in order to actually get to the node, you have to walk through the list of modifiers and whatever effects that they cause. So yeah, the classic thing that you learn very early on is that order is absolutely essential, because it is I say it's a visitor pattern because what it's not really a visitor pattern, but what happens is that in order to get to the node, basically every modifier gets a chance to like interact or expose like some values before you go to the next one. And so in that regard, and the other thing is that the node can see the entire modifier list. So that's sort of the other thing I was referencing where, in Flutter, like widgets, it's harder for widgets to see other widgets and them to talk to each other. The node is responsible for, each node in Compose UI is responsible for holding on to that modifier list. And it can look inside that list and say, like this modifier wants to alter the measurements, or like these 3 modifiers out of the list of 6 want to alter the way that I am measured, or they want to alter the way that I'm exposed to accessibility services, or all different kind of like mechanisms of a UI toolkit are able to be modified. It's named really well. I complain a lot about the naming of Compose and all the things around it. Modifier, spot on.
Nailed it.
Yeah. It's just it's this thing where it will just go down the list, the list of modifiers, and essentially ask each one like what do you have to contribute to the different aspects of this layout node, whether it be measuring, accessibility, drawing, whatever. So it's almost like if you're familiar with like OKHTTP, we have interceptors, and interceptors are a list, and each one is executed in order before that final real HTTP call goes out. You can add headers, remove headers. You can do things with caching or authentication or whatever. Everybody gets a chance to like contribute something before the real thing happens. And modifiers are basically interceptors for each node in your Compose UI tree.
Nice.
Yeah, it's a cool,
a good mental model.
Yeah, I hadn't thought of it, but it is exactly the same thing.
It's a good mental model.
When you find stuff like patterns like that, they tend to show up a lot in ways that may not be immediately obvious. Like another sort of interceptor-y or modifier-y like pattern would be like in JSON or Mashi, where you can define these type adapters or JSON adapters, which you can use to modify the way that certain values are rendered into JSON or parsed from JSON. And you can actually stack them up where you have multiple ones apply, where you can have like an ISO 8601 like date, and you can have that date get rendered to a maybe like a long, but then that long gets rendered to, because JavaScript or JSON doesn't technically have longs, it might get split up into like high bits and low bits or something. And that can actually happen with 2 different adapters that are both being applied in the same way that, interceptor order matters and they can do things, in the same way that modifier order matters and can do things. It's a pattern that's widespread, but like if you don't know how that works, you might not realize that that's sort of the same thing you see in a bunch of other libraries.
Cool. I think we have about 5-10 minutes, unless you want to go longer. But can still do some code if you want. Up to you, really.
I like Modifier is the one name I wouldn't modify.
Yeah.
Good job, Mark. But I think other than that, the only other thing I think I really wanted to show, so you can look at like, you can go and look at Mosaic, which is a pretty simple example of how to create your own Compose or whatever. But even with Compose UI, you can start just command clicking into these things and seeing how they're built, especially if you start with something simpler like Mosaic or Compose Web is also extremely straightforward. Every HTML tag basically has a composable function. So there's like a div function, and you can command click into that div function or control click. I don't want to be exclusionary on my desktop platforms. And see how it's actually implemented, and it's really straightforward. And so let me see where you're at. Do I see the same thing you see here? I got lots of windows. I'm trying to find an example of one that's like relatively you're really high level here.
Yeah, maybe you want to go into the preferences screen or something.
Yeah, something where we get down to like a button or this is pretty good. Because we can see sort of the modifier and what they've done in the API design of Modifier is really clever. Modifier is an interface, and they implement that interface on the companion object, which is pretty wild. It basically means that you can implement Modifier on a class and implement, you're forced to implement like these functions, which are very, very like Haskell-y or whatever. They're very functional functions. Does this work? But also those functions are exposed, like I hesitate to use the term statically, but I don't know what we call it in Kotlin, but they're exposed like on the like Modifier is also an object, and so when you hit dot, like you see like the low level these low level functions that Modifier exposes. And what that allows them to do is make this chain where each one of these, hopefully we can see the list aspect here. The way the list is built is you basically start with the existing Modifier chain, and then this is just like appending one more item onto the list. And so fill max width is appending this, based on, there's a conditional here, but like based on the conditional, it's either adding this item to the list or the value that comes out of this function call to the list. And it's returning that, because this is a function expression, it's returning the new list. And so then when we call whatever we call after this, clickable, clickable is seeing, well, like Modifier is basically the empty list. And so we're appending the first item, and then when clickable goes to append itself, it sees the one item list from above, and that's how we wind up with the list of modifiers in this like clever syntax. I believe it used to be more list-like. I can't remember the exact syntax, but it was almost like the list of syntax where each one of these was specified like an item.
Was that before they renamed them to modifiers?
I don't remember.
I seem to remember before it went to alpha that they were called something else. I don't remember what though.
Oh. Yeah, that sounds right, but I don't remember either.
It's been too long.
But that shows you how that list is built. And then I'm not sure what the best one to do here is. Ultimately, so that's like that's also an attribute, right? That's like a thing that ends up as a property of a node. This is going to take forever to get to the bottom.
There's a few layers.
This is pretty low. It's not the one I've never used reusable, but when you want to actually like put a node into the tree, you use this compose node, or I guess this reusable compose node function, and this is sort of like the directives that the compiler and runtime end up understanding that you don't really need to pay attention to. But this is like this is what produces that item into the actual tree that gets rendered. And so ultimately every single composable that you call will end up in a call to compose node. So whether I go to row, or I don't really want to text, because text I'm pretty sure takes a while to get to.
There's
maybe image. No, they all kind of go to layout. Yeah, a lot of Compose UI goes this way. Also, I thought it was hilarious that you like describe this stream as talking about Compose UI a lot. Like I would be talking about Compose UI. You would be shocked to know how much time I've actually spent with Compose UI. I am like the beginner's beginner at Compose UI.
This is the perfect stream for you now.
I feel, yeah, it is. No, it really is. I feel extremely, I've gone to extreme depths in the compiler and the runtime, the very lowest level, so that I can understand how they work. There's all kinds of concepts down there, like frame clocks and snapshots and this stuff that we haven't really talked about, of how the Compose actually works itself. But then I've taken a hard left and built my own things on top of that, and have done so little with Compose UI that it's kind of a shock that you invited me on to.
I mean,
can I say that I love the fact that you know how the compiler works and you can't do a text with a background? I mean, I love it. I mean, that's the opposite of myself. So I have no idea how the compiler works, and probably
you two make a great team.
Just the middle.
You just make a great team.
Yeah. Definitely a lot of awkward conversation, like, you know, Jake, what do you think about this? Ivan, what do you think about this? Yeah, that's a lot of weird conversations.
The only other thing I would show really quickly, and then we can wrap it up before I expose really how little I know, is this is sort of the node type that everything in Compose UI is built on top of, and it's really complicated. It is akin to what both Vue and VueGroup.java are trying to do. It is much simpler than those and does much less. You know, a lot of that functionality is pulled out into modifiers and into higher level composables that compose that functionality together. But there's still just a ton of low level UI toolkit stuff that is just inside this node. It's definitely responsible for things like layout and measurement passes that would be used to in the existing widget toolkit, and is the entry point for drawing. And so, yeah, you scroll. Here's the tree. This is what makes it a tree. Each node has its list of children. It is bidirectional, so you can go back up. And then I don't remember if modifiers are in here somewhere. They are. This is the other thing that actually surprised me. When I talked about how modifiers, you pay for recreating that list. There's also just a lot of stuff that runs when you update the modifiers.
Oh, wow.
That's a lot of if.
Yeah. And
is this AI?
Yeah. This is a classifier. Basically, this is there's a classifier model.
But you can see they're suffering through an ad, or maybe that's just me.
No, it's
you can see,
a bunch of people are probably watching an ad right now. Unfortunately, that's how Twitch works.
Well, when they come back, they can see. You can see kind of the how I had talked about the almost like categories of modifiers, where you can affect like measurement, or you can affect drawing. These interfaces are basically the categories of effects that a modifier can have, and they're all like, they all have to be known. Ultimately, if you add a custom modifier, like it will bottom out in one of these existing effects that you can have. And so you're drawing, or you're laying out, or you're doing something with listeners or input. And then this is also the way that each node can kind of inspect that list and see what's inside of it, and potentially hook in a little more. Like when you put a click listener in a modifier, like how does that lambda eventually get invoked, or a key listener or whatever? And it is because the each node can inspect that list and see like, oh, I know I have a modifier that has a lambda inside it that's waiting for click.
Mm-hmm.
Whereas in something like Flutter, you would like click would be a widget that would just wrap other content, and it would solely be responsible for clicking. Everything inside of it would know nothing about that. And then you might propagate down like touch state or whatever, so that it shows something when it's clicked.
That was one of the disturbing things when I started looking into Flutter, the idea that you were wrapping everything. And I was like, okay, this is so weird. I'm going to write so many live template in IntelliJ because I want to. And then I realized that there are so many already live template because there are so many wrapping. And then, they already, and I was like, okay, but this is weird. That was one of the things that I struggled wrapping my head around at the beginning.
Yeah, it's one of those things that's very like pure, almost idealistic, where it's like everything is just a widget and that's the only mechanism, and so everything is literally built on top of that. If you want to replace something, you can. Whereas like in Compose UI, like you cannot change how like focus, other than through the APIs that are provided to you, you can't change how like focus or key events or click handling or any of that works, because it's built into the core to each node itself. But that's usually it's like a fine trade-off, because usually those aren't the things that you want to fundamentally change. You just want to hook into drawing or key events or whatever. And the thing you really want to focus on is like the literal, like almost higher level. I hesitate to say higher level because Compose UI actually has lower level nodes than the widget framework. But in comparison to Flutter, they are much higher level, because you don't have those things exposed, and you can focus on more what's actually being put on the screen rather than intermixing what gets rendered with its functionality in the same like syntax. Yeah.
I think
it's a lot of stuff, my friend.
There's a lot of stuff in here. This is
mamma mia.
This is the lowest of lowest. But hey, in comparison to Vue.java, I don't know if you have line numbers on. I don't.
No, we don't want to go there. This is 1,000 lines. That's 1,000 million.
Yeah, 1,400 lines. I mean, there's a lot in here, but yeah, it's you can click through here, and it's fairly understand. I mean, there's a lot of stuff I don't understand.
Look at that. Sebastiano, you don't want to click. Don't click. Please don't click.
No, the first ones are from the wrong thing, so I would need to find the right one, and I cannot be arsed right now. I think I can do this, but
lock up your ID.
Whatever, it's fine. I can just maybe open it. No,
where is
all places?
Where is it?
Android.view. There you go. But
here you go.
Doesn't like I don't have the sources downloaded. I think maybe I do. I don't know. Anyway, it's like that's very that's not all the. There's more than that.
No,
there's definitely more.
There's way more than that. This is like the.
Oh, you're in the stubs.
This is our the R8 version probably.
That was the stubs. I don't have the sources apparently.
Yeah, I know.
I saw someone comment about Zach who left Square to go to Google.
Yeah.
I have tons of issues with Google as a company. I really enjoy the Android team though, and the stuff that they work on. Like that experience of it was actually fantastic. It's really just the larger company and the way it operates, and how it treats its products, and how even I'm sure you've read like how people get promoted inside Google, not in the Android team, but the rest of Google. It's why we have the meme about 23 chat apps and stuff. It's just it's just too big. Like I would love for Congress to go in and just gut them into like 50 companies and force them to. They're too big, therefore they should fail. But Android teams, I had nothing but really, I certainly have problems and issues with stuff on Android, but in general, the experience of being on the team and stuff was fantastic. And so, like I was really excited to see that Zach was going to go and work on Compose UI and stuff because he's really passionate about it, and they're doing amazing stuff.
Should we finish up on the opinion piece, or do we want to add something else? I'm happy either way. I think we have covered a lot of ground today, and you can always come back, Jake. You're always welcome.
Yeah, I'll go. I'll tell you what. How about I go and learn Compose UI a little bit?
Sure. You can also talk about the non-UI stuff if you want, because we haven't really covered that much in terms of code. And I think it would be interesting to see, the slot table implementation, like that sort of stuff. If you know about that and you want to come back and talk about that, I would actually love that.
Yeah, that stuff, like there's a lot of really interesting technology inside the runtime itself. The slot table is one, which is how when you call, remember, or even where your Compose nodes are held and stuff. There's a lot of really cool stuff. I mentioned how we didn't talk about how functions are actually executed.
Yeah.
There's a sort of, we did see very briefly that the Compose node implementation where there's all these like granular calls to, I think, the recomposer, and like Compose just keeps track of all this stuff so that it can try and execute the minimal amount of changes possible to correctly apply changes to your state objects. And that's why it can hit 60 FPS instead of like 2 FPS, because if we didn't have the compiler plugin doing all that magic, just the amount of stuff that would have to happen at runtime would grind it to a halt.
Yeah, it's actually, at least it was for me when I started doing Compose UI on Android specifically, and I started doing things. I was thinking about, oh my god, this is going to be so slow. Performance is going to be like, I'm allocating things like there's no tomorrow, and it actually is fine, and that's black magic to me. I'm happy that there is that. But
I do feel like there's probably only 3 people that understand like the complete picture of the black magic, because I still definitely don't understand a lot of how that happens, how functions are partially re-executed and how that gets decided and stuff. It's it really goes to show you that even though I feel like I have an understanding of fairly low level bits of Compose, this is like an iceberg of a thing where there's just a whole another level below that I'm very happy to stay above and just sort of know that it works and trust the people working on it to get it correct.
At least you know that they have tons of tests.
Amen to that.
Yeah.
Okay, so let's wrap it up for today. There are still questions on the chat, but if we keep going, we're gonna end up way later than we normally finish, and we already do very long streams as it is. So, Jake, please come back whenever you want. Just let us know. Thank you a lot for, the stories, the anecdotes, the explanations, and all the things that we have learned. Thank you, Yossi, for the stuff. And even if you have anything else, I'm done. I haven't talked much today. That's fine.
Yeah. I just want to do the closing round of usual things. We are gonna have chat on October the 10th. We're going to have a nice chat, I guess, about the book. Read the book, buy the book. If you are watching this on live with us and you don't like ads, you can subscribe for free using your Amazon Prime subscription. Uncle Bezos gives the subscription for free every month. You can connect your Amazon Prime to your Twitch account and you can subscribe for free. We get a couple of dollars. We buy stickers. You don't get the ads, and probably you can win the stickers back. So it's a good return of investment. If you're watching this on YouTube, please, I'm gonna do the whole shenanigans. Smash the like button, smash the subscribe button, or ring the bell, whatever. Yeah, I can probably point to the way. So jokes aside. Yeah, you can subscribe and you can keep an eye on VODs on YouTube. We are running giveaways on YouTube every week. You can win an IntelliJ license. Just give it a shot. And thank you for the support. Thank you for being with us every episode. And thank you, Jake. This was very cool. I know more. There's a lot of stuff that I don't know yet, but this is good. This is super cool. Thanks.
Yeah, thanks for having me.
Thank you, everyone. See you on Sunday with chat. Bye.
Ciao, ciao.